Okay. Hello, Algebra 3-4. This is your new activity for your Thursday, Friday asynchronous day. So we just had to change things, and here we go. So you're gonna watch this, take notes. I'm gonna say, take notes, or follow along, or I don't know. And then you're gonna try the questions in the Google form. So I'm gonna make a Google form for you. And yeah, we'll just see. All right, so we're gonna solve these. I'm gonna reference SADMAP as often as I can remember to do so. And then I'm also gonna draw a picture. So we're drawing number lines. Okay, so let's do number 1. X plus 9 is less than 21. Okay, so this is just like a one step. So I'm gonna add or subtract, right? SADMAP first. So take away 9, take away 9. So that means X is less than, oh dear, because that would be 12, right? Okay, so that's my solution. So on a number line, so you have to make your own, you are going to draw this. And I usually try, so if this is 12, well no, actually let's put 12. Because sometimes if the worksheet is pre-made, you kind of have a view of what the options are. So say this is 12, 10, let's go by 2s, 6, 4, 2, 0. Okay, so my boundary point is the 12. So I'm going to put a dot at 12. It's an open dot because there's no equal to, and I'm choosing a number that's less than 12. And so the way I've set up my line is I already knew which way my thing's going to go. But anyway, I'm going to check a dot over there. So I'm going to say, is 8 less than 12? Yes, that's true. So then my line is going to go this way. And you can kind of make it yep. So that's the solution. The solution set is all these numbers that X can be. Okay, so let's do a little bit more complicated one. So let's do purple again. So same thing, I'm thinking about SADMAP, so I'm going to add or subtract first. So I see that plus 4, so I'm going to subtract 4 from both sides. And then I have negative 2x is greater than or equal to negative 16. Okay, so again, I added subtracted. Now I'm going to check if I can divide or multiply. So the number in front of x is a coefficient, it's multiplying. So I'm going to divide both sides by negative 2. Okay, so when I have a negative number, the inequality symbol flips. And we talked about that in class if you were there. If not, please go back and look at the notes. I think it was number 6 that happened. Okay, so I have this inequality. I'm going to sketch a number line. And I'm going to put 8 in the middle because I want to talk about why maybe it is 8 and which way it could go. 2, 0. No, that's a 0. So let's choose 2 points. And again, if you had me for Algebra 1-2, we did this a lot. That's a 0. So I'm going to check this point and let's check 12. The thing I'm going to do though is to find my boundary point. So it's 8. It's a filled in dot or circle because it's equal to. So because of this. Okay, so we're going to check. Let's get blue. So let's check 0. And you have to check in the original inequality. So negative 2 times 0 plus 4. Is that really greater than or equal to negative 12? 0 plus 4. 4 is greater than negative 12. Okay, so I almost don't want to check the other side because that works, but let's do it anyway. Check. Negative 2 times positive 12 plus 4. Is that greater than or equal to negative 12? Right, so I'm asking myself, is this true? Negative 24 plus 4, which is negative 20. So that is false. Nope, not true. So this is false. This is true. So because 0 works and because 12 doesn't work, I'm going to draw my arrow this way. I'll fill it in. You don't have to fill it in though. Oops. Well, okay. That's an arrow. Okay, so that's how you would draw the graph if you weren't sure about flipping the sign. So the other thing I'm going to say here, let's do it in pink. So like this arrow here, oh dear, flip when dividing by a negative. Okay, 5 minutes. I don't want to talk for forever because I know you don't want to listen for forever. So this one's a little bit more complicated, but it's still just an inequality. So same thing for a SAD map. Before I start solving though, I'm going to simplify. So first I'm going to distribute. I could divide, but I don't want a fraction. I don't want that 3 to be 3/2. What is that? 14 minus 2x. Okay, now I'm going to start to solve. So I'm going to add or subtract first. I want my x to be positive, so I'm going to do plus 3x plus 3x. I'm going to go back to purple. Or actually, can I subtract 14 on this step? Are you okay with that? Okay, so I have negative 10 is less than or equal to x. Oh, well, that's great. Perfect. Amazing. So I'm going to draw a number line. Oops. And I'm going to put, so it's negative, it's less, or it's greater than rather. So in theory, if I have negative 10 here, my arrow should go to the right. 12, 8. Well, okay, 8, 6. These are negative. 4, negative 2. Okay, so my boundary point again is the first thing I can plot because that's that negative 10. It's a closed circle because of the line, the equal to part. And it's greater than. So I'm thinking that if I plug in negative 2, like that should work. So I'm going to check this over here. So I'm going to say 4 minus 3, 3 times negative 2. Is that less than or equal to 2 times 7 minus 2? A little double negative. What is that? Plus? So that'd be 9, 18. You do this first, everyone. Order of operations. So that's actually negative 6, but plus. So this would be 4 plus 6, which is 10. 10 is less than 18. So it is true that it goes this way. I get a true statement. So I'm going to draw my arrow that way. So all these points are going to create a true statement, a true inequality statement. If I check over here, it should give me a false statement. By over here, I mean like negative 12. Okay, so the other thing you can do is plug in a number here, right? So this is what we do if we're just given an inequality and it's either on this side or the other side. But it's good to check with the original. So check with original is what I want to write. Okay, great. Let's go to the next slide. Okay, so what you're going to see is a couple problems for you to try about absolute value inequalities. So absolute value, remember, is the V shape, and its outcome has to be a positive number unless something's been sort of flipped around. So we're going to use SADMAP still to solve this, and then we're going to graph it, and you should see some graphs like we looked at today. If I had you today. If not, that's okay. All right, so step 1, add or subtract. So I'm going to add 2 to both sides. Absolute value of x is greater than 2. Okay, so remember for this to work, it needs to be, so when we had equations, we had 2 options, right? We had negative 2 or positive 2. So this is a little bit difference. So I'm going to draw my number line first. And I care about 2's. So 1, 2, 3, 4, 5. 1, 2, 3, 4, -5. Okay. So right now my boundary point is 2. And I'm going to have an open circle. So I'm going to put that over here at 2. So I'm going to put an open circle here. Okay. So what needs to happen is I need a number where if I take the absolute value, it has to be bigger than 2. I know. So what we're going to see is something like this. Let me get blue. So I'm going to check, maybe let's check 5. And then let's check, let's do -5, actually. Okay, so if I check this, so if I plug it in, absolute value of -5 minus 2, is that really bigger than 0? So I'm using the original equation. So the absolute value of -5 is 5. 5 minus 2, is that bigger than 0? 3 is bigger than 0. Yes. Okay. So this works. Okay, great. So then I'm going to check +5. So I'm going to say, okay, does the absolute value of 5 minus 2, does that, or is that greater than 0? So absolute value of 5 is 5. 5 minus 2 is 3. Yes, this also works. So right now it looks like I can go both ways, right? Okay, well, let's check another point. Let's check 0. So I'm going to say, is the absolute value of 0, take away 2, greater than 0? So 0 is 0, so -2 is not greater than 0. So this part doesn't work. Oh no. So what's happening? Well, I'll tell you what's happening. This -2 is important. So it's like a second boundary point. So I'm going to do a little bit of erasing. So I'm just going to say, oops, that's definitely not an eraser. So I'm going to erase this. Okay. So I want my green point back. So let's think about -2 for a second. If -2 were also a boundary point, I have 2 boundary points. So right now I know that if I go to the right of my +2, that's what I have here, that works. If I go to the left of my other boundary point, that also works. So what happens is that everything in between the 2 boundary points is not a solution. I know. So if you think about a picture, it's like this stuff in between is not a solution. Everything else is. And let me maybe grab a different color for that. So let's do pink. Not a solution. So we're going to either have a picture like this where the arrows are going away from each other, or they're coming together. I know. All right, let's look at the next one, and maybe that will help solidify it. Let's do, I'm going to kind of draw some. I wonder though if I can, well, I could zoom out, but that's not helpful. Okay. Anyway, I digress. All right. So right now, I don't have anything to add or subtract. So I'm going to deal with my function. I'm going to deal with my absolute value. So right now, either this little expression is set equal to 8 or -8. And here I have equal to, which is nice. So if I sketch a picture of this, I'm going to have... oh, but it's, hold on, I'm like skipping a step. Because this one, I just had x, so that's why I was able to jump here first. So what's happening is that I have x plus 4 is less than or equal to 8. Or, I need to zoom out because I forgot. or and rather, x plus 4 is greater than, okay, so this is an important thing. So notice that I changed the order because it's negative. Changed sign, direction. Okay, so I'm gonna actually erase, oops, I need to erase this for a second. And then I'm going to like move that for a moment. That was my picture. And then I'm gonna move this. Okay. All right. So let's go back to blue. So for this one, I'm gonna subtract 4. So x is less than or equal to, what is that? 4, right? At the same time, I'm going to subtract 4 over here. Remember that I changed the sign. So x is greater than or equal to negative 12. I know. So when I sketch this now, I'm trying to find a good spot. There is no good spot. So my boundary points change from 8. So this is different from the first one because I have to like deal with the expression. So some of the ones you're going to practice look like this. Some of them look like example number 1. So that's why I was pausing, because I was like, it's not going to be 8. It's going to be negative 12. And then 10, 8, 6, 4, 2, 0, 2, 4. Okay, so now my boundary points are 4 and negative 12. So I have a closed dot and a closed dot. And then x is less than 4, which means this way. X is greater than or equal to 12, which means this way. So what's happening is that I'm going to like choose a number in between. I'm going to choose 0. So I'm going to check that this is true. So I'm going to pick 0 on purpose because 0 is easy to operate. And this is a check, right? So 4 is less than 8, which is true. So it's this whole space in between them that is the solution. So this is what we saw in the compound inequality. I want to get rid of these arrows just for a second. So anything in that green band is a solution. Anything in that green band is a solution. So the difference, because it took me a second to think about, so it's possible to take anyone, everyone. I'm going to move these, sorry. And I guess you can't see that though. That's not very helpful for notes, eh? Okay, so the difference between 1 and 2 is I didn't have to like solve this first part. So like didn't have to simplify, I guess I want to say, rather than solve, or solve, oops, inside the absolute value. So the boundary points I could use for my graph. Here I did have to do that. And so you have to like take this extra step. And this is happening for a reason. So you're going to consider the positive. So the positive. And then for the negative option, you're going to change the sign. I know. And then you're going to get a compound looking thing. It just so happens for that example. I know, it's a lot. We're going to obviously talk more about this in class. It does get a little bit tricky. And so just like be kind to yourself, be nice. And yeah. Okay. Bye.